And welcome back. We continue on to our journey of arrays with the concept of two-dimensional arrays. If you remember, our original array, we diagrammed it like this, showing it as a single row of information starting at a memory location and moving to the size, starting at 0 and ending at n minus 1 for the size of the array. A two-dimensional array is fundamentally the same exact thing. So 0 would be here, 1 would be here, 2 would be here, 3 would be here, 4 would be here. So if I had a 5 by 5 array, I would end up with a memory location set that you could mentally treat like a two-dimensional grid, like in Excel, just with the reason I dropped into Excel. So the reference to anything here starts off as a row-column reference with what row are you in, and then what column do you go to. So in this case, this guy right here would be 0, 0. This guy right here would be 0, 1, which Excel won't do for me because I didn't put it as a string. But there you go. There's the concept of this. So our design on this, though, doesn't look like this. What we have to do is change the size and put a second dimension out here at the end so that it looks like this. Dimension 0, dimension 1. This is just showing you that you can do a two-dimensional array. As a side note, there really isn't a huge limitation on how many array sizes you want. You want a three-dimensional array, which would basically be emulating like I don't know, a square of atmosphere. So you can kind of mentally picture this as going back this way, so you can get a giant cube. So that's a cube. You want to mimic this in terms of time, so it's a cube changing over time. You could actually do that. I made a mistake on typing that just to show. So there's a four-dimensional array. Could you do a fifth-dimensional array? Sure, a fifth-dimensional array would be fun. Yeah, no. Programmatically, these get harder and harder to deal with, and they take more and more memory. But just know that you can have virtually unlimited number of arrays inside here. If you get into quantum physics and string theory, you'll find yourself dealing with multiple dimensional arrays all the time. But for us, we're going to stick with 2 dimensions right now, so a two-dimensional array. And you can almost think of this as representing a class of, here are the grades for an individual student. So here's the grade 1, or grade 0 in effect, grade 0, grade 1, grade 2, grade 3, grade 4 for Bob. Unfortunately, we can't have a Bob over here because it's only going to store arrays of one type. So if we wanted to, back to that parallel array thing, we would need to make an array of size 5 to hold the names, and a two-dimensional array to hold all of the grades for each of the class. So that way we get all the individual grades for each individual person, all hooked together by their index. So let's show that in code. So if I wanted to, and again I'll use 3 just because it makes it easier, to do a 3 by 3 array of grades, I could do double grades, and then I give it size. Size. Hope I spelled it right. So this provides for us a two-dimensional array, uninitialized, of 3 by 3. How do you initialize it, you say? Good question. We can give, as we did before, all of the values in one set. But the catch is here we don't have one set. We have rows of sets. So think of it this way. The outer mustaches, the outer braces, indicate the complete size of the array. Inside of it, each set of braces that we use are going to indicate one row of the array. So if I wanted to, this would be 0, 1, 2, 3. That's the first row of the array. Then I would do another one, 1, 2, 3. And then I would do another one, 2, 3, 4. So there's 0, 1, 2. So that gives me my 3 by 3 array. That's how I would initialize it if I had all of the values. If I don't have all the values, guess what? We'll just show you another way. It'll give us errors, but we're used to that. I could do something as simple as this. Initialize the first value to 0, leave everything else away, and that will give me an initialized array set that's all initialized to 0. It happens automatically for us. So you can initialize, you can build like we showed you before, you can declare the variables and not give it the size and it'll kind of fill it in. However, everything's got to be pretty much set up to be the same exact size. So that's a cautionary thing. So I'm going to use the second one just because I wanted to initialize everything to 0. And now, here we go. Actually, no, let's do this. Let's comment this one out just to show. So if I wanted to print this array of grades, we've been using a very common standard feature. All arrays, for the most part, have had some version of for loops to loop through every item in the array. Well, we now have both rows and columns to loop through, which means we need, you got it, 2 for loops. So you need a for, and we'll do this int row equals 0, row less than size, row plus plus, and space it out for readability. And then inside this, of course, we'll do the same exact thing. We're going to copy pasta this thing and then change row to column. Kind of makes it a little more readable for you to understand what exactly it is you're manipulating. And then we're going to print it out. So if we wanted to print out grades with a space between it, well, we need to print out the row and the column and then a space. So this is going to loop through our array, row 0, column 0, 1, 2, back around to row 1, column 0, 1, 2, lap back around, column 2, row 2, column 0, 1, 2. So this is going to loop through our set of arrays, and then at the end of each row we want to print out an end line. And that will allow us to manipulate and show the way we print out and deal with multidimensional arrays. And there you go. 0, 1, 2, or 1, 2, 3, 1, 2, 3, 2, 3, 4, boom, there's my 3 by 3 array. This is stock and trade, the standard way of manipulating two-dimensional arrays. 2 for loops go through it. If all you want to do is manipulate a column, you can manipulate a column, just making sure that you fix the secondary the primary row size and change the column to go 0, 1, 2, 3, and then for whatever size you do it. Or you can do it the other way. For a given row, I want to manipulate each one. You can change these guys out and do it with one loop, but for the most part, you end up with this 2-loop thing going on. For example, let's say I want to change a given student's grades, whoever the student in the first row is. So I can take grades, I can pick the first row, and then I can change the secondary row and say he gets bonus points for bringing brownies to class of 10 points each. So that now bumps that row for every single grade by 10 points. And if I take this and I copy pasta this again, and print it out twice. I think I'm going to print out a blank row line here just for funsies. Actually, I think I printed a couple of them. And that way it'll space it out a little bit for us and we can see. There you go. The first student, I changed all his grades. I gave him 10 more points because he brought brownies to class. Although nobody ever brings brownies to class. So there you go. You can manipulate a single row or a single column if you fix it, and then use a loop to do whatever you're going to do to it. So this allows you to manipulate things in rows and columns just by using single-dimensional arrays. But two-dimensional arrays work just like this. And we're getting kind of long, but we'll go through one thing. What happens if I want to print this array? What happens if I want to write a print grades just like we did before? Well, if I do this, I have to tell it what it's getting. In this case, it's getting doubles. It's going to be getting a two-dimensional array. And then, of course, I need to tell it the size of this thing. And you'll notice instantaneously I get an error right there. And if you hover over the error, it says array has incomplete element type double. That's because for everything other than the first dimension, you have to tell it how big things are, which means you need to have a variable declared above the function prototypes to allow this thing to work. We're using the same exact thing, so we're just going to move the whole thing up here. But that allows us to put that size right in there. And now it doesn't complain so much. So for multidimensional arrays, you have to tell it what the size of the variable is in the second dimension, the third dimension, and all of them. You have to give it this. Otherwise, it doesn't know what to do with that. And then when we come down here and we give it grades, it still needs that. Consonant S. And we're going to come right back up here and steal that output that we had. Because it works so nicely. And then here, instead of printing it by that, we're just going to call print grades. Same exact way before. We just pass in the name of the grades and the variable size. And now what you should see, assuming I didn't make any mistakes, is it works the same way. There's our 1, 2, 3, 2, 3, 4. So you can see we've now simplified our code quite a bit just by allowing us to pass multiple dimensional arrays around. Ta-da! Look how nice our main is. We put all the ugly stuff down here. But that's how you pass it in. And remember, this is passed by reference, so don't screw it up down here. You might want to make it a constant. Anyway, hope that one went over well. Hope you're having a great day.